Hello and welcome! In my previous video, I've presented some free tools for building a VFX production pipeline. One of the tools was Kitsu, a web-based production management system similar to Autodesk Shotgun that can be used to track production progress of VFX, animation or film projects. To use it, you have to set up a server. Having one spare Raspberry Pi, I thought why not use it as a standalone Kitsu server, a cheap alternative to professional hardware. So in this video, I'm going to show you step by step how to set it up. Raspberry Pi is a popular microcomputer used for countless applications. For my Kitsu server, I've used Raspberry Pi 4 with 8 GB of RAM, which you can get for around €75. That's pretty low for a 4-core CPU machine. As Kitsu will be performing some tasks involving video encoding, I think 8 GB of RAM is a minimum. Also, a 64-bit operating system would be needed. The default Raspberry Pi OS is 32-bit, and it can't handle 4K ProRes encoding. So I've decided to use Ubuntu. For the purpose of this build, I will also overclock the Raspberry Pi CPU to 2 GHz and add an external SSD drive, as the default microSD solution isn't perfect for long-term usage. To keep the overclocked Pi cool, I recommend having a case with active cooling. The one that I'm using is Argon 1. So, to prepare your Kitsu server, you will need a Raspberry Pi 4 with 8 GB of RAM, microSD card, SSD drive and some case or adapter for SATA. Make sure that it supports UASP, which stands for USB Attached SCSI protocol. This will make the data transfer much faster. And a case for Raspberry Pi, preferably with active cooling. At the end of this video, you should have a running server with a ready-to-use production management system, which you can further integrate with your pipeline and software. You will find description of the whole process and all the commands used here on my blog. Check the address in the description below. We're going to start by downloading Raspberry Pi Imager to prepare our SD card. From the Imager menu, choose Ubuntu and Ubuntu 20.04 LTS 64-bit version. Then choose your SD card and click Write. With the SD card ready, we can launch our Raspberry Pi. Ubuntu doesn't need any installation setup. It will boot straight to login screen. You can use the default username, which is Ubuntu, and same for the password. For some strange reason, however, Ubuntu might be claiming that the password is incorrect. Just wait a moment and try again. You will be then asked to change the default password. If your Raspberry Pi is connected by Ethernet cable, then you already should have access to the internet. If you want to use Wi-Fi, then some additional setup is needed. Type this command to list all network devices names. I will configure it to use Wi-Fi, so I'll need the Wi-Fi 0 device. We will edit NetPlan configuration by typing this command. And let's insert the following configuration to use our Wi-Fi. As we want our server to always be accessible under the same address, we will disable the dynamic address configuration and specify a unique address in your local network. Make sure this address is not being used by another machine. I'll put here .130. Gateway should be the address of your router. Same for the name server address. We can now save it and quit the editor. On my blog, I will also post configuration for Ethernet connection. Once ready, apply the changes and connect to your wireless router by executing sudo netplan apply. Let's reboot, and with the internet connection ready, let's install any software updates or system upgrades by typing sudo apt-get update. Here I've encountered another strange Ubuntu behavior. It's not allowing to update because of a lock from some process. Just wait a moment and try again. Then let's perform sudo apt-get upgrade. With all that done, and after a reboot, you may install a graphical environment for Ubuntu. I would recommend Xphase, which can be found in Xubuntu. You can install it by typing sudo apt-get install Xubuntu-desktop. During the installation, which will take a while, you will be asked to choose a display manager. I recommend choosing LightDM. Soon you should be able to log in to your system. If, as me, you are using the Argon One case, you will want to install the software that controls the fan. The default installation script from the manufacturer will not work under Ubuntu. You can find an adapted script on this website. We now can move on to installing Kitsu. Kitsu is constructed of two main elements: Zoo, which is controlling database and all under-the-hood actions, and Kitsu, which is a front end for our project management software. We have to start with Zoo. You can find detailed documentation on this website. I found, however, some descriptions to be a bit confusing, especially if you're not a Linux command line guru. I had some trouble installing it, so I've tried to make it more clear. First, we'll need to install some additional software required by Zoo. Postgre for database management, Redis server, Python, Git, Nginx web server, FFmpeg for encoding videos, JPEG libraries, and lastly pwgen for random passwords generating. We will now create a Zoo user and its folders by typing the following commands. We'll create and operate in a virtual environment. With the virtual environment activated, we can install Zoo. Next, create a folder to store previews. Now we'll be creating a database. Let's open a new terminal window, but keep the previous one for later, as it's already working in Zoo virtual environment. We will first switch to Postgre user. And now create the database. Now type PySQL to start Postgre command line. We will change the Postgre user password by typing \password. You can specify your new password. This will also be the password to access the database. You can close this terminal window and we'll continue in the other one by typing db_password equals, put your password here, zoo init_db. This created tables for our database. Open a new terminal window. Let's now remove some warnings in Redis logs by editing this configuration file and adding one line at the end of the file. Save it and exit the editor. Let's create configuration folder. Now we'll edit a configuration file to run zoo as a daemon and put the following information in the file. Save and exit. Let's create the log folder. Now we'll create a new daemon to be managed by systemd and put the following information in. You will of course want to put in your database password and a secret key, which you can generate in a new terminal window by typing pwgen space 16. Copy one of the generated passwords and paste it in here. We can configure some more stuff in here. For example, Kitsu can send notifications or new user invitations by email. You can use your Gmail account for that, or any other mail server that you are using. To use Gmail, we have to add the following information. Let's save it and quit the editor. We'll now create a G-Unicorn configuration file and add the following information. Save and exit, and create another one for systemd. Insert this data in the file. Save and exit. Finally, we'll configure the Nginx web server and put in the following information. Save and exit. Let's now remove the default Nginx configuration and replace it with our own. We can now start our daemons and restart Nginx. Lastly, let's make sure that zoo will be automatically starting with this system. Now we can move on to installing and configuring Kitsu. For that, let's grab it from GitHub. We'll have to adapt the Nginx configuration that we created previously and add this information. Save and exit, and let's restart Nginx server. To start using Kitsu, we first have to create an admin user. We'll do that in the other terminal window in our virtual zoo environment with this command. Use your correct database password and your email address. And let's initialize Kitsu data. At this stage, Kitsu should be already working. You can check that by opening a web browser and typing localhost or the Raspberry Pi IP address that we configured in the beginning. You can log in as the admin using the email address that you've just saved and a word default as the password. You should be prompted to change that password. Kitsu should be accessible from any machine in your local network. The last step is to move the whole system to an external SSD drive and perform the Raspberry Pi EEPROM update to the newest stable version, which allows to boot from USB devices. We'll start by downloading and installing PiClone, which will copy our SD card to the SSD drive. Let's change the directory to Downloads and download the software. We'll install PiClone with the following commands. Connect your SSD drive and let's start PiClone by typing sudo -e dbus-launch PiClone. In the first field, choose the SD card on which we have our Ubuntu installed, and in the second field, choose the SSD drive. Check the New Partitions UUIDs and then click Start. Confirm the operation and wait until it's done. We now have our Ubuntu copied to the SSD drive, but it will not boot as we have to perform EEPROM update. The easiest way will be doing it on Raspberry Pi OS. So let's turn off the Raspberry Pi and take out the SD card. On your computer, launch Imager again, and this time choose Raspberry Pi OS and write it to the SD card. You can overwrite Ubuntu as we have copied it to the SSD drive. When ready, turn on Raspberry Pi with the SD card inside. Let's open a terminal and perform a system update. When it's done, reboot the Pi. Again, open terminal and type. Make sure the status is set to stable. Save and exit. Now type the following command to update the EEPROM. Reboot to apply the changes. Next, we'll have to change some files to enable USB booting. Connect your SSD drive and go to this website and download the code. From the zip file, we will only need the folder boot. Now select and copy all files with .dat or .elf extensions and paste them to the boot partition of your USB SSD drive, replacing any existing files. Next, in a terminal window, change directory to /media/pi/system-boot. That should be the boot partition of your Ubuntu SSD drive. And perform this command. Now let's edit the config.txt, which is also located on the boot partition. Here, make sure that the Pi 4 section looks like this. The last 3 lines are overclocking the CPU and GPU. Save and close the editor. Again in terminal, create a new script on the boot partition called auto_decompress_kernel with the following code in it. Save and exit. Make the script executable. We'll need to create one last script. Paste this code in it. Save and exit. Again, make the script executable. And that is it. You should now be able to start the Raspberry Pi with SSD drive only, without the SD card. And your Kitsu server should be accessible in your local network. If you have a global static IP address on your router, you can set a port forwarding, for example, forward port 5555 to port 80 on your Raspberry Pi IP address, which in this tutorial was 192.168.1.130. That way, your Kitsu will also be available online by typing your global IP :5555. To manage your Raspberry Pi, you don't need a monitor and keyboard connected. You can use SSH for command line management, or you can install XRDP on the Ubuntu, which will allow to connect with remote desktop. I also recommend checking this website and their suggestions regarding security of your Raspberry Pi. My Raspberry Pi server is now running for a couple of weeks and I haven't encountered any issues so far. I hope this video will be helpful. Please write your comments or questions. If you have other ideas how to use Raspberry Pi in VFX pipeline, definitely share it. Thank you very much for watching, and please subscribe for more videos about VFX and its history.